Okay, I apologize. I ran out of time on the first video, so I'm doing a second video for example 10. This example is really important. So again, I want you to look at the rules as you do the problem. Rule number 1 is to write the equation in standard quadratic form. This is not standard quadratic form. How do I know that? Well, my b is 4, and then I'm followed by the x, and then I have a negative 1x squared. Okay, so actually this is a, I'm sorry, a is negative 1. This is not correct standard quadratic form. So I need to reverse this. I need to rewrite it as negative 1x squared plus 4x. And then I'll have it in standard quadratic form. If you want to put a plus 0 for your c, you can. This problem does not have a c. You can put a 0 if you want to. I'm not going to. So now I have a and I have b. And so this is standard quadratic form. That's the first thing you should do. Next, we're going to find the vertex. Now remember, the vertex is an ordered pair. Again, read the rules on the front of this worksheet in order to figure out, the steps. It also tells us that x is the opposite of b over 2a. Well, I've already labeled my a and b. If b is positive 4, then opposite of b is negative 4. And then 2 times a, well, a is a negative 1. So this is going to be a negative 1. So I'm going to have negative 4 over negative 2, which gives me a positive 2 for the x coordinate of the vertex. So put a positive 2 in the x position. If you read the rules on the front of the page, it tells you to find y. You copy x into the equation. So I'm going to find y by copying, let me write down the equation, it's negative x squared plus 4x. I'm going to put this x into the equation. Now be careful here. You see this negative? This negative is out in front of x squared. It's not a negative 2. That would be wrong. It is 2 squared with a negative in front. That's different than if you were to square a negative 2. Be very careful if you're using your calculator here. This is going to be negative 4 plus 8, which is going to end up giving me a positive 4. So my vertex is at 2, 4. Now I'm going to go ahead and plot that. 1, 2, 3, 4. So we're going to have an orange dot for the vertex. Then I'll change colors. We'll get something different for the axis of symmetry. Okay, the axis of symmetry, you don't have to do any work for the axis of symmetry. Let's see. All you have to do, because this is the axis of symmetry. This right here is the axis of symmetry. We've already done that. We already know what this equals. It equals 2. So all I have to do is write x equals 2. Now it is very important that this is a line. The axis of symmetry is not a point, it's not a coordinate, it's not a dot. It is actually a vertical line that passes through the vertex. So there we go on that. Let's change our colors. We'll get green. I don't think I've used this green. Okay, if you read the paper, this is where my explanation is not the best, but it says, if necessary, force x squared to be positive. Okay, now wait a minute. If necessary, you're going to force x squared to be positive. Well, right now, x squared is a negative, and we cannot factor a lead term, a quadratic with a negative lead term, not with our techniques. So this is necessary to force a sign change. And let me show you how you do it. It's not as hard as it sounds. We have negative 1x squared plus 4x. I'm going to set that equal to 0, and I'm going to force x squared to be positive by moving everything to the other side. So basically, negative 1x squared and 4x are going to come to the right, and this 0 is going to move to the left. So my new equation, I'm going to have 0 on the left, x squared moves to the right and becomes positive, 4x moves to the right and becomes a negative. And now I have a positive x squared. You only do this for step 3. You do not use this for any other steps. That's very important. But only step 3 did we force x squared to be positive. Now I can factor this. This is actually a GCF problem. The GCF is x. and that leaves me with x minus 4. This is a factor, so I set it equal to 0, and I get x equals 0. This is another factor, and I set it equal to 0, and I get x equals 4. Now, these are your x-intercepts, but they have to be written as ordered pairs. That's on the sheet. If you look at your sheet at the beginning of this packet, it says x-intercepts are ordered pairs. So I have to write these as ordered pairs. One is going to be 0, 0, and the other one will be 4, 0. That is very important. Notation matters. X equals 0 is a line, but 0, 0 is an ordered pair. It's a point. Okay, so let's go ahead and plot our points. This is our first x-intercept here. 1, 2, 3, 4. Here's our second x-intercept. And we'll change colors so we can go to the next step. Let's go to red. Now let's go to hot pink. All right, number 3, find the y-intercept. If you look at your notes, it says to find the y-intercept, you plug 0 into the equation. Now, you're going to stick with this equation. You do not force a sign change for anything except step 3. I'm sorry, well, I've got these steps numbered wrong. I apologize. I've got 2 step 3s, and that's incorrect. But you don't force a sign change to find the y-intercept. So we're going to copy down the original equation, negative 1x squared plus 4x. Sorry. And we just plug in a 0 for x. And we're actually going to get 0 for our y-intercept. Now, just like I told you, this is also an ordered pair. So do not write y equals 0. That would be a horizontal line, and that's not what we're looking for. Now, this is the same that I already had, so I'll just circle this in pink because I already had that. And now I can connect my graph. This is a downward U. Now, hold up. We already knew that. How did I know that this U was going to open down? It's very important. Let's get a highlighter here. Okay, here's how I knew. If you look at the original problem started with a negative 1x squared. And that means it's going to open down. Okay, I'll give you some other examples. Let's go up here. This is a positive x squared. And so that means this one will open up because it's praise hands. Let's look at the next one. This is also a positive x squared. So this one will open up. If it starts with a positive x squared, let's look at these. Okay, this is a positive x squared. So this would be opening up. If it starts with a positive x squared, it opens up. If it starts with a negative x squared, it opens down. Okay, so number 10 is going to open down. Number 11, okay, hold up now. This is a negative x squared. See that negative x squared? So this is going to be a downward U. If you don't graph anything else correct, make sure it's pointing downward. And the same thing for number 12. Number 12 is a negative in front of x squared. So if you don't figure out anything else, just draw yourself a downward U. If it's got a negative in front, it's going to be pointing down. If it has a positive x squared in front, it's going to be pointing up. Okay, let's finish domain, range, and increasing and decreasing for this particular problem. I know we have talked about this a lot. If you've watched my videos and you've been in class, you're bored to tears. But just in case you missed it or, you just need some refreshing, let's look at it one more time. State the domain. The domain goes from left to right. So if you look at this quadratic, it's going to the left, to the left, to the left forever. That's negative infinity. And it's also going to the right, to the right, to the right towards positive infinity. So it's going to the left, that's negative infinity. It's going towards the right, that's positive infinity. That is our domain. Our range, let's go to, what do we not use? This thing is pretty. All right, range is from the bottom to the top. So you go from the bottom to the top. Now, how low is this thing going to go? It's like the limbo. How low can you go? Well, you can go down to infinity. So this thing is going to go down to negative infinity, and the top is going to be at 4. So my range is negative infinity to 4, and I put a bracket at 4 because it actually touches that point. It actually crosses through 4 on as the y coordinate. All right, and then increasing and decreasing, the last one, and we will be done. Let's do orange again. All right, for increasing and decreasing, you always sit down on the ride on the left-hand side. So here you are, you start on the left, and your body up until this moment would be increasing. Now, after this moment, your body will be decreasing. Again, this is all on the front of the worksheet, but the turning point occurs at the x value, not the y. And this x coordinate is 2. So 2 is what you call your turning point because your body is turning from increasing to decreasing. And at that very moment, if you've ridden roller coasters, you know there is a moment in time that your body is neither increasing or decreasing. That's why we always put parentheses for every single problem. Ever, if you're asked for increasing and decreasing. So let's see, it's increasing from the left, which is negative infinity, up to that turning point, which is 2. And then it's decreasing from 2 to the right. Now make sure you put positive infinity. Why? Because 2 comes before positive infinity, not negative. Some people get confused here because they'll say, but it's going down. It is going down, but it's going towards the right. It's going from 2 to the right, okay? And the right is positive infinity. Your x coordinate is what you look at for increasing and decreasing. So that is example 10. If you need another example, look at my previous video.